Welcome to the Didactic Smart Grid Energy System by the LORENZO Group, the first comprehensive experimental curriculum-based program for students and engineers to learn about the topics that are changing the future of energy. Within the past 10 years, electrical energy has revolutionized, developing a need for highly technological concepts for operating, such as wind energy, solar energy, and fault detection. In the search for an effective use for a smart electric network, a revolution is needed to develop smart grid technology as an educational tool, thereby creating a capable professional with a more complete, integrated training to prepare him to the challenges of the real world. This didactic equipment is an excellent tool that allows teachers and students to participate in a step-by-step process that results in practical knowledge. Electrical energy is changing the basic processes such as generation, distribution, and transmission. It is urgent to modify the way that students are learning. If we continue teaching only theoretical aspects about smart green technology, students are missing an important component of the learning process and causing them to not be able to give adequate responses regarding smart grid technology. The LORENZO Group wants to do its part to ensure the next generation of engineers will be prepared to solve the problems that merge theoretical with experimental concepts, using one of the most important hands-on technologies making a significant impact in education around the world: the smart grid system. When the smart grid is implemented, it leads to real benefits. For instance, to improve environmental conditions and to save money. The smart grid reduces the need for fossil fuel peaker plants and enables greater use of renewable energy sources such as wind and solar power. Moreover, the smart grid generates new and rewarding careers in the expanding electrical energy sectors. With that in mind, it is essential that smart grid students be aware of the role that technology will play in the future of energy, and to know how they can make the best choices for their professional future. The smart grid system has the following goals: connects theoretical courses with real-world energy issues, engage students in learning basic and advanced concepts of electrical energy, and enable students and teachers to interact with several electrical and digital systems at the same time. You can find the following components in the smart grid system. The smart grid system is powered by 3 types of energy: wind, solar, and the generation of conventional energy using fossil fuels. The wind energy system allows to modify conditions in the generation system like wind speed and pitch angle. In the solar energy system, solar radiation, DC to AC converters, efficiency in solar cells, microgrid operation, and interconnection of solar energy to the grid are studied. A conventional generation system using fossil energy is presented as a constant source of energy, and the system allows the generation of a flat amount of energy. All these systems can be connected to the grid in order to make the distribution of energy more efficient. The distribution system is the key factor for connecting the grid with the loads and the load elements, which can create combinations for reproducing the real situations in buildings, homes, and factories. For industrial sectors, the smart grid is the best response for world energy problems, which require engineers with excellent knowledge about the smart grid. The power system protection is covered by digital relays that show information about the performance of the system, as well as power factor correction and the monitoring of several points on the grid. The control and supervision are developed by the SCADA, or Supervisory Control and Data Acquisition System. The LORENZO Group invites you to learn more about this powerful and innovative smart grid station.
Wind energy has become one of the most important renewable energy sources. Wind energy plants can convert mechanical energy to electrical energy without emitting polluting gases and at a very competitive price. The LORENZO has designed a new trainer to allow students to study the functions and the operations of a modern wind power plant. With this trainer, it is also possible to study the relationships between a pitch control system and the wind, to analyze the mechanical as well as the electrical parameters within an induction generator, to perform experiments on the starting of a wind system, on the doubly fed induction generator and on the fault ride-through conditions. The wind speed and direction are simulated by means of a device composed of a controllable power supply and a fan, and their parameters are measured through an anemometer. The power of the wind is emulated by a brushless motor controlled by the software. The brushless motor is mechanically connected to a generator that develops the same speed as the encoded speed of the brushless motor. The generator is then connected to the back-to-back converter that is needed for the control of a doubly fed induction machine. That is, an induction machine that is fed from both the rotor and the starter, because in some operation, the rotor energy can flow both ways and may come back to the converter. The trainer also includes a 3-phase power supply, a power circuit breaker, and a 3-phase power meter. The hub module connects all the different devices of the trainer to the PC through the RS485 cables. The communication between hardware and software is in accordance to the Modbus protocol. A SCADA software is used for data acquisition, data communication, data presentation, and control of the actuators. This trainer has a modular structure that grants teachers and students extreme flexibility during the study of the related topics and the performance of the experiments. The trainer is provided with a well-detailed manual that includes both the theoretical principles underlying the wind power plant operation and the step-by-step description of the suggested experiments.